The following scientific film was originally made in 1991 and has been shown at various medical conferences in the original German and English languages, yet never before released. For this new DVD release, we have used most of the original video and sound, yet replaced some scenes with updated images and film to reflect technological improvements made since 1991. We have maintained the original English narration, which does not reflect such changes. Whereas this film was made using the Ergonom 400 microscope, it should be noted that the new Ergonom 500 has similar capabilities, yet is smaller, much easier to use, and is now being offered commercially. The capabilities attributed to the Ergonom 400 in this film also apply to the Ergonom 500. More details can be found at www.greyfieldoptical.com.
In the beginning, facts do not speak for themselves, but one has to speak for them until they have become common knowledge of humanity. People who had discovered new relations therefore often had to fight for recognition of their scientific findings until their message was understood. The most famous example is Galilei with Copernicus' heliocentric picture of the world. The same happened to the German researchers in cancer, Dr. von Brehmer and Professor Enderlein, with their findings. In the blood of patients suffering from cancer, they always found a microorganism which went through a life cycle in the culture test, starting with the virus form, via bacterial cultures, up to fungoid developments. Before Brehmer's and Enderlein's works were published, Dr. Nebel had already made this cyclogenia of the oncomixer forms A, B, and C, so that the priority in the field of endobiosis research belongs to him. He cultivated the three oncomixer forms, always reproducible from tumor tissue. The works of the Canadian biologist Dr. Nessens are based on the findings of the above-mentioned researchers and correspond on the whole with their findings. In his cyclogenia he names the microbe somatide and proves as well the life cycle from the virus to fungoid forms. All forms of development that could be observed in the culture test can also be found in human blood. The larger forms, however, like spore threads, rods, conjugation rings, only in the blood of people threatened by, respectively, suffering from cancer. The occurrence of this constellation is characteristic for classifying a blood tested to be cancerous or endangered by cancer. This is a vital blood strongly infested with small and large microbes in the serum and red blood cells. These blood tests are generally carried out with dark field microscopes. The problem arising is that all light microscopes so far allow a magnification up to 1,800 times. Thus, however, the ultravisible particles can no longer be identified. Meanwhile, the German scientist called Olbrich has succeeded after 30 years of work in developing a new microscope. It is characterized by highly disintegrated magnifications that go far beyond the efficiency of conventional microscopes so far. By help of this revolutionary microscope technique, it is now possible to make living viruses visible and to prove correlations in microbiology and histology that could only be assumed so far. Just recently, these findings were submitted in a special meeting to an expert group of leading scientists in England. These international researchers point out the efficiency of the microscope to be a big progress. The advantage of the universal microscope, named Ergonom 400, is due to the following technical dates: resolution up to 100 nanometers, magnification of more than 25,000 times, high contrast, high depth of focus, no chromatospheric aberration. Before dealing with the symbiosis, we will show some preliminary tests. In the photos to come, certain trembling movements of microorganisms that are often regarded as Brownian movements can be observed in the serum. These plastic balls of 497 nanometers in diameter was soaked in oil. Characteristic for the Brownian movement is the striving together and scattering of the particles without an aimed movement of their own. The grade factor of the following diatomae, named Amphiflora pellucida, is 250 nanometers, which is there are 4 bars per 1 micrometer. In comparison, now a photo with the usual light microscope where the texture of the lines is no longer visible. This is a grating grid with embedded latex balls of a defined size of 220 nanometers for scanning electron microscopes. Even with dry objectives of 40 and 60 size, the balls can be seen, which is not possible with a traditional technique. Here the same measuring grid was inclined to 30 degrees. Once the middle height with the least depth of focus is focused, and afterwards the depth of focus is enlarged to the infinitely variable maximum, so that the whole grid is shown exactly over the whole difference in altitude without distortion, including the embedded latex balls. This test was to demonstrate the depth of focus without losing the sharp definition. With this depth of focus, which is unusual for light microscopes, stereoscopic pictures can be made as shown with this bone structure, in which the trabeculae are sharply defined over the whole cutting width. Besides the minimal infection of the serum, one cannot see much in the following dark field photo. Because of the small output in light, this problem would still increase with higher magnifications. The new microscope therefore works with a different principle, which is a variable gray field, as the next pictures with the same blood sample show. Here microbes of smallest up to middle size can be noticed. Besides, the membranes of the erythrocytes are partly strongly affected. From various cells there are already fibers coming out. Brehmer calls this group of microbes, which appear in blood, Siphonospora polymorpha. In special cases, as can be seen here, if the slide preparation only shows weak contrasts, even the gray field is no longer sufficient. In order to make fine structures visible, the reversal contrast method, as used by Olbrich, must be applied. The forms specified by Brehmer can be easily observed and exactly identified with such an efficiency of microscope. With vital blood tests and magnifications of 20,000 times, the membrane fluctuation with erythrocytes is clearly visible. It consists of the pressure of the cytoplasma, the migration of the cytoplasma, and the active membrane work. In the blood of people suffering from cancer, a flagellation of the membranes is obvious. This flagellation is due to intracellular microbes which are in constant movement. They are flagelled and often move into the serum. Examples can be seen in the picture on the bottom left, on the bottom right, then once again on the bottom right, on the bottom left, on the top left, and in the middle of the picture. In this picture, a mobile rod with ball-shaped ends can be seen in the middle of the red blood cell, which was classified by Brehmer as copulation ring. In the next example, there is a big rod in intracellular resting position. This white blood cell has actively phagocytized micromaterial. It can be seen how via the outer membrane pseudopodias are stretched out to catch foreign substance. The micromaterial can still move strongly, but the area of the cell cannot be left any longer. Afterwards, the particles phagocytized are transported into the area of the nucleus. The activity is reduced the closer they are drawn into the center of the macrophage. With people suffering from cancer, endangered by it or otherwise weakened, the phonospora takes different shapes. Depending on the nutrition, there are different fungoid forms. As mycelium, as spore fibers, as unmovable fibers, as tubes or ascospores, as yeast forms, as aspergillus forms, or as pseudomycelium with blastospores. As sporangia chains or coccidia sproutings. In vital blood which is damaged, all forms mentioned above can be seen more or less strongly, and therefore this parasite development is classified by many researchers as mycotic, respective fungiform. These living examples show long moving fibers with a spore at their ends, short moving or rigid fibers also with spores at their ends, long rigid fiber, yeast sproutings, fibers with spore capsules at strongly damaged red and white blood cells. This blood sample was taken 4 weeks, the next 1 week ante etam. Here you can see pseudomycelia with blastospores. This here is a more distinct form of pseudomycelia, and here a sporangia chain. Here another example for pseudomycelia with blastospores. On the bottom right, an aspergillus form. On the top left, a fiber sprouting. Here are mycelia formations in various forms. These are not, as could be assumed, small fibrinous hypha, as the vital blood was already stale. In the next situation, the same picture once again in the reverse contrast method, and finally in the gray field presentation. In its marginal area, this ascospore is set with small spores which are gradually moving away. On the right, there's a big sporangia chain. Here a flagelled sporangia which is just about taking off. And here the sporangia can be seen as individual detached form. On the top left, a flagelled rod, as well as a longer sporangia chain, and on the right bottom quadrant a full rod. Thrombocytes show similar structures in the method by Scheidel and Snegotzka. Various pitches are moving and rigid fibers as well as tube forms. The diagnostic meaning of these structures is as follows. Rigid fibers mean carcinous tendency. Tubes mean precancerous tendency. Spore fibers mean dental focus. Moving fibers mean tendency to diabetes. According to Scheidel, all forms can be seen as mycoplasms, or better, creator of fungi. If the following blood samples are subject to a well-aimed stress test, there are as well differences in the evaluation of unaffected and affected blood. A general acanthocytosis is striking with cancer patients, which means that the erythrocytes gradually take the shape of a thorn apple. In the thorns we find again forms of siphonospora which leave the cytoplasm and migrate into the serum as soon as the intracellular nutrition offered gets smaller. An acanthocytosis is often discussed in literature to be the consequence of an A-beta-lipoproteinemia or of hemolytic anemia, hepatocirrhosis, or after application of heparin. The stress test shows, however, with patients endangered by cancer, this phenomenon as well on exertion, so that besides these criteria mentioned, a humoral pathological connection is very likely. With intracellular parasitism, hemoglobin is used up, which can also be seen in tumor patients with frequent anurocytes, which is red blood cells with little hemoglobin. Their resistance is generally going down and the serum gets hemolytic. The size of this microbe in the thorns is 150 nanometers, as can be seen with the tabella by Olbrich. We already frequently mentioned the dependency of microbial development from the composition of the milieu. Tests with a change in milieu showed that the big forms of microbes, as can be seen here in the middle of the picture, are stimulated to faster growth in a milieu rich in carbohydrates. These are staphyloforms or arthrospores and sporangia chains with or without flagella in various sizes. This is a small sporangia chain with lateral flagellum. Besides that, there are yeast sproutings in a coccidia way to be seen. The smaller forms of microbe dominate in a nutrition solution rich in protein. Within carbohydrate solutions, especially mycelium formations are obvious, fast, and slow rods. Here a slow rod, and here a fast rod. In order to find out the respective development of this microbe, the blood was washed several times and afterwards mixed with various solutions. The artificial serum doesn't seem to be affected at first. After 10 minutes, microbes from the erythrocytes migrate into the serum and increase very fast in number. Please watch especially the change of this Y shape. There are mostly giant forms developing, which can only very rarely be seen in vital blood. This Y-shaped hyphen formation and the accompanying carrier of spores are an example for it. The Y hyphen changes into a rod, shows contraction lines in the membrane, constricts and divides into ball halves, and finally the individual balls push off each other. The whole procedure takes about 15 minutes and is shown here in an abbreviated way. The migrating ascospores consist of a big ball-shaped cell with marginal active and smaller spores. The Y hyphen as well as the ascospore are the result of a change in milieu. Professor Enderlein named the whole of these phenomena endobiosis. Dr. von Brehmer looked upon the whole cycle to be symbiotic and a partial aspect to be parasitic. This was at the times of these two researchers and is still today a completely different view of the entire microbiology. Brehmer's findings were checked by other researchers and repeatedly confirmed. The true evidence, however, for the existence of endobionts in blood and their changeability is brought about in this film. The fact that on the base of Olbrich's supermicroscope a microbe cyclogenia has been provable and which is here introduced publicly for the first time can be regarded without exaggeration as a double-world sensation. A life cycle of zoonoses such as malaria or toxoplasmosis has been proved. Intracellular parasitism is accepted, as far as I know, only for viruses and some few mycotic infections. However, not for microbes of this classification, with possible changes between viral, bacterial and fungoid existency depending from the terrain. Terrain or milieu signify the composition of humor, which is the concentration of protein, lipids and carbohydrates, the constellation of electrolytes, the pH value, the utilization of oxygen, the efficiency of metabolism, the status of immunity, the affliction of mesenchyme with waste products and many others more. Big microbes, as already mentioned before, were only to be found in the blood of seriously damaged patients. In this case, it is a 65-year-old male patient in semicoma who was operated 6 years ago because of cancer of the sigmoid. An annus praetor was made, and half a year ago he was operated again because of metastasis in the liver. He was treated with chemotherapy and then metastasis generally appeared in the bones, lungs, abdominal cavity and brain. He died about 1 week after the taking of blood samples. This microbial growth in giant shape was evoked by a carbohydrate solution, which is a proof for the fact that the balance of power between resistance and parasitism was more than unstable. It also proves that the administration of saccharide has to be stopped absolutely with people suffering from cancer. Ascospores are containers in which small particles reproduce and from a certain size on are set free to infect the serum. These cysts are described by Nebel as well as by Nessens. Individually appearing round forms can have come into existence from the material of an ascospore as well as from its hyphen form, as the morphogenesis from the former Y form shows. These experiments contradict the opinion that the fast theta movements of the smallest particles in the serum are chylomicrons with Brownian movements. The Brownian movement certainly takes effect on all small particles. If they are, however, able to move by themselves, then they also work against molecular thrusts in the liquid, especially if they are flagelled or have different organs of movement like this fast rod, which can be seen at normal speed and in slow motion. The microbe discussed can be found in its basic forms in all life forms, in the blood, urine, sperm, in juices of plants and fruits. According to the cyclogenia by Nessens, there are only small forms in the blood of healthy persons to be found. It must be therefore correct to speak of symbiosis here. In a morbidly changed mixture of humor, this microbe transforms into bacterial and fungus forms and can be looked upon in this stadium as parasite. After regaining immunology by biological cancer therapy, for example, parasitism is instantly restrained into the symbiotic phase. The following vital blood is characterized by total infection of serum and cells, as well as marked formation of mycelium. It was taken from a 39-year-old woman with bilateral mastectomy, metastasis in lung and bones, dyspnoea and great pain. The same blood, after 5 weeks of biological cancer therapy, brought a regression in infestation and regeneration of the blood cells. It was accompanied by freedom from pain and regression of metastasis in lungs and costae. This cyclogenia developed by Brehmer shows the changeability of the symbiont from the viral and bacterial to fungiform phases. Because of its manifold forms in the culture test, Dr. von Brehmer calls this microbe to be polymorphorous. The grouping from 1 to 7 proved to be optional saprophytic, which means these phases of development appear depending from the living conditions in putrefaction. The existence in the blood is a measure for the humoral load with waste material. Group 8 in the bottom right, however, proved to be parasitic and appears with tendency of cancer. Professor Enderlein calls the bacterial form Leptotrichia buccalis rubin, the mycel form Mucor racemosus phrasen. Other researchers hold the opinion that the endobiont, due to its rod form and ball-shaped end, was basically to be classified into the group of proprioni bacteria, which is to be classified similar to diphtheria, as shown here with the Neisser's staining. The aspects mentioned here do most certainly not fit into any known bacteria classification, especially not because of the claimed cyclogenia. All observations, however, prove its correctness. The question of symbiosis or parasitism could be asked in the same way as health or illness. A sound vital blood is characterized by the following criteria. All erythrocytes have the same size. All red blood cells are circular and dumbbell-shaped in cross-section. Their load of hemoglobin is normal and proportionally distributed. The red blood cells do not conglobate. In the intracellular, no somatide activity can be observed. Phagocytosis is uninhibited. Their stress test is negative. There is minimal serum infestation, preferably small forms. The thrombocyte test is negative as well. Only short, moving fibers can be seen. All this is expression of a sound humoral constellation. The defensive condition is strong enough so that somatides are almost completely inhibited in their whole development. The blood of patients endangered by cancer shows the following characteristics. High infestation of blood cells with spores, sporangia and rods, perhaps presence of anulocytes. High infestation of the serum with big and small forms. The stress test is positive, which is general acanthocytosis follows. Big microbes appear in the intracellular as well as extracellular area. Possible anisocytosis, often with simultaneous acanthocytosis, which was not provoked. The thrombocyte test is positive, which is formation of hypha rather than fibers. Rouleau formation as expression of a disturbed membrane charge and aggregation. The membranes of the erythrocytes get sticky and cling to each other. The blood of patients with a tendency to cancer is damaged in its humoral behavior to such an extent that with impaired defense condition, somatides can be seen in almost every stage of development. It is wrong to say that the phonospore polymorpha was the germ of cancer, pure and simple. It is, however, correct that this microbe represents the humoral dysfunction from a certain morphogenetic phase onwards and thus has to be understood as manifestation of dyscrasia. These are the reasons for Brehmer's test to be an excellent indicator for early cancer detection and for the control of therapy as well. Brehmer's method consists of two partial tests. The first one as a whole blood test in thin layer, the other one as a stained smear specimen. Both specimens have to be investigated and evaluated under the microscope in respect of percentage of infestation and intra- and extracellular stage of development for the microbe discussed. These tests are made, for example, in the laboratory mentioned here. About 10 days after withdrawing blood, the results are in your hands on such a form, including an individually tested treatment proposed and a geopathic stress classification test. In blood tests with the universal microscope, it became apparent that monochromatic light allows a further distinction. Part of the erythrocytes showed a radiant corona, the other part not. Similar observations were already described by Dr. Reif, USA. He found out the microbic autofrequencies of tumors, treated the thus infested animals with these rays and succeeded in bringing down the tumor to complete healing. This phenomenon can be explained with the intact functioning of the erythrocytes to be able to get into resonance with the frequency of the light waves used. Non-functioning cells do not have this possibility. This resonance reaction occurs in the yellow spectrum the most distinctly. The optic resonance seems to deliver indications for the same chemical structure and function. If the resonance range of a cell is found, it can be killed with a wavelength of its own frequency, as it reacts specially sensible in the resonance range. When life in a vital blood specimen seems to have ceased, there are still slight differences in the resonance behavior which show in the reverse resonance method, while the phonospore forms go on existing for weeks or months. The new microscope works with normal light so that live observations are possible in contrast to the electron microscope. This microscope is a construction by Hartnack, Paris, from about 1860, and the other one on the right is a modern version. Type 1 offers magnifications up to 300 times. Type 2 magnifications up to 1800 times. With both microscopes, the slide preparation was filmed under the same conditions. It is a section of a small intestine of pike. Comparing these two photos, there is hardly any difference to be seen. This photo was made with the 1860 microscope of Hartnack, and this one was made with its modern version. With the universal microscope named Ergonom 400 by Olbrich, a much better resolution can be gained. It has to be regarded as a true further development in the optical field. The microscope tripod is done in a massive way so that differences in temperature do not cause mistakes in adjustment, and possible vibrations do not cause blurred adjustments. The fine focusing is more sensible than with the usual microscopes because of its highly resolving magnification. Let us have a look into the work of histological research with this microscope. A first-class European Institute of Research made the following photos available. Most of the preparations are live cultures which were grown in a so-called Rosenkammer. These works will make animal studies unnecessary. All preparations were filmed through the border of the chamber. In this example, ciliated epithelium can be seen working together in tissue compound in normal and slow motion picture and under different magnifications. In the culture test, individual ciliated cells can be observed trying to join the whole compound. In the end, they strive for an integration which corresponds to their physiology. It is worthwhile mentioning in this respect that the activity of the cilia in the respiratory tract is paralyzed for 15 minutes with smoking 1 cigarette. This thick section of brain matter is shown here in confocal method. It is comparable to the tomography method and means that different layers are copied without hindrance of other objects in higher or lower layers and with particular demonstration of the vessels. This specimen is from a monkey which was in a Russian space capsule for 9 months. Here the tail of a tadpole was shined through and the circulation of the blood can be exactly observed. Efflux via an arteria flows through the capillaries, reflux in the venous system with the main arteria and main vein. At a closer look, one can see that in the capillary area only one erythrocyte each can pass the lumen. Here various nerve cells are shown with their respective cell organelles like the trigoid substance, the neurofibrils, and the constantly moving vesicles with neurotransmitters. They are produced in the cell body, get transported in the axons to the telodendron in order to transmit the electrochemical impulse. Under the microscope, the transport of the neurotransmitter in the neurite can be exactly observed. It is also obvious that at certain points there is an extracellular transport along a neurite which has never been published in technical literature so far. It can be seen in the following sequences. In the living culture test, even the contractibility of nerve cells can be seen. The contractibility of nerve cells is only very rarely pointed out. The following pictures show cells of the heart muscle under various physiopathological situations. Asynchrone processes of contraction and dilatation as consequence of conduction defects. Rhythmic retardation in the sense of bradycardia. If it was physiological, all cells in the cell compound had to react in a common and synchronous way. Here as well bradycardia. Tachycardia, condition of fibrillation, and finally arrhythmia as consequence of irregular action potentials. This sequence shows the infarct in a test with tissue culture. First, the arrhythmic action is to be seen, then the rhythm accelerates, shifts over into the condition of fibrillation, and finally ends with the decay of the individual cells. Please have a look at the cell on the top left side, which decays the first. Afterwards, the one on the left bottom side, and finally the big cell on the right side of the picture. This time we are confronted with death in a microscopical way. It is, however, an immense biochemical process. In this case, it can be explained by a changed permeability of the membrane with an increased inflow of calcium into the system of the cells. With this leukocyte, the amoeboid locomotion can be seen very clearly. On the basis of a chemotactical mechanism, they are involved in inflammatory processes by elimination of germs via phagocytosis. There's other foreign substance as well which can be taken in and transported away by them. After this excursion through histology, we go back to our previous topic. In order to ensure a better understanding of the processes about the microbe explained by Brehmer, some pictures were recorded in slow motion, respectively time-lapse method. This stage of development is a rod with ball-shaped ends. The locomotion is done as ring contraction. In the traditional microscopes, the microbe only appears as a tottering disc. The phagocyte is filled with microbes with the exception of the marginal region. The microforms of the phonospora are in the centrifugal part strongly locomotive, however no longer locomotive in the central part. This blood sample was first of all washed several times, and afterwards the so-called serum is free of infestation. The time-lapse pictures show the constant growth of the microbe, which can only be due to the helplessness of the erythrocytes. This Y formation, which will soon appear in the right side of the picture, appears first of all as protozoon, changes into a long rod, undergoes several contraction stages, and finally divides into individual cockles which are flagellated. Here it is a capsule with emigrating spores classified as ascospore by Naessens. This fast rod is a form of development which moves that fast so that it is not perceived under normal circumstances. The magnification via the Ergonom 400 in slow motion shows that the microbe consists of two parts. The movement is serpentine, most certainly flagellated. Symbiosis or parasitism. Both is correct. The activity or inactivity lies in ourselves, in our humoral household, and can only be understood under the aspects of humoral pathology. The fact that protozoans have a cyclogenia, and Brehmer proved such one as well for the Siphonospora polymorpha, the fact that Enderlein found a development of the endobiont, Nebel proved 3 different oncomixer forms, and Naessens discovered the cycle of the somatide, strongly recommends to examine other microbes upon a possible development. Preliminary studies were already made by researchers of former generations. The names of these men of merit should not be forgotten. They were all belligerent representatives of the pleomorphistic idea. Dr. von Brehmer, Germany; Professor Dunbar, Germany; Professor Enderlein, Germany; Dr. Hasumi, Japan; Dr. Naessens, Canada; Dr. Nebel, Switzerland; Dr. Reif, USA; Dr. Rosenau, USA; Professor Scheidel, Argentina; Professor von Zelt, Germany; Dr. Sklenar, Germany; Dr. Spengler, Germany; Dr. Weber, Germany. The findings of this film are mainly based on the works of Brehmer, Enderlein, Nebel, Naessens and Scheidel. All observations that have been discussed are like opening a door to a vast field of research in which especially the sciences of medicine, biology and physics are challenged. The new microscope technique is already in use with scientific research groups. Its triumphant advance will, especially in medicine, impart new findings concerning the question about health and illness. It will hopefully be a help for humankind, vexed by a global decay in the quality of life, to make diagnosis, therapy, research and application more reliable.